one final example that's going to show us how to treat double or triple bonds. And what you want to do is, in terms of priorities and attachments, consider double bonds as two separate single bonds to that atom, or triple bonds as three. So just for example, if you just have this carbon-carbon double bond, the way you can essentially view that is, instead of a double bond, just two separate single bonds to carbon. So essentially, there's one bond to the carbon, there's a second bond to the carbon. So we're viewing it as one bond to the carbon, a second bond to the carbon. All right, so let's look at this example down here. We have our chiral center. Again, as we've been doing, look at the atoms directly attached. We have a bromine, hydrogen, carbon, and carbon. So it's easy to say priority 1's bromine, priority 4's the hydrogen, but how about the two carbons? What you want to do is think about what's attached. This carbon at the top, if it helps, you can draw in the hydrogens. Right? This carbon is attached to an oxygen, a hydrogen, and a hydrogen. Okay, now let's look at this one. It's attached to an oxygen, and we'll say an oxygen and an oxygen, since this double bond counts twice. It counts as two single bonds to an oxygen. So effectively, that carbon's bonded to three oxygens. The three oxygens wins. So priority-wise, that'll be priority 2. This one will be priority 3. Now, you can use your trick here because the hydrogen is out, but I do want to show you kind of one other way to simplify a complex molecule if you do have to manipulate it to get the priority 4 group to the back. A lot of times what I like to do is just simplify it as just a basic tetrahedron. Here's my tetrahedron, and then on that tetrahedron, just write your priority numbers. We have 1 back, 4 out, and then 2 and 3 in the plane. And then this small molecule here is really easy to work with and manipulate. So what I can do, let's say we hold 3 constant, then I can rotate 4 to the back, 1 into the plane, and 2 out. Once we do that, we still have 3 we held constant, 1 over here, 2 here, and 4 here. Now, just draw your curved arrows. This goes around to the right, which tells us an R configuration, and that's the configuration of the original molecule. Now again, this one probably would have been easier just to use the trick. So hydrogen, or priority 4, is out. So we would go from 1 to 2 to 3. It looks like S, but since priority 4 is out, it's actually R. One kind of special case to know is if in a molecule you have a double bond and this isopropyl group that essentially, based on what we talked about, would tie, because here's a carbon attached to two carbons, and if we treat the double bond as two separate single bonds, this carbon's attached to two carbons. So how do we know what to do here? Basically, if you run into this, specific circumstance, the double bond wins in terms of priority. So for example, if you were to have this molecule, the oxygen's priority 1, the hydrogen's priority 4, and then these two groups, based on all the rules we've discussed, end up tying with one another, we give the double bond priority. So that's 2, and that's 3. So then draw your arrow. This one goes around to the left, so that's an S configuration.